You're in a Kotlin session, no matter what the title says, and who knows what Kotlin is? 2.5 people in the room. Not bad. All right, so I'll do a short introduction just to let you know what I'm talking about and then proceed to my main subject. So Kotlin, first of all, is a programming language compiled to Java bytecodes. So it's in the same area of all those new modern JVM languages like Scala or Groovy or Selenium or many others. It's developed by JetBrains, the IDE company. So it's supposed to be like a very ergonomic, very usable language, both from the language concept side and from the tooling support side. The biggest question when I tell anyone that I'm working in a language is like, why? And there is a pretty good answer why. So if you think about the situation we're in now, there are very many Java developers. You can see a little fraction of that mass of people at this conference. And we're pretty happy with the platform. Have a really good platform that is around for quite a long time, and it steadily evolved over that time. So Java is great in that respect. And now I think about Java the platform versus Java the language, there is a huge gap. Because Java the language, as well as the platform, came about in 1995. And if you remember that time, what was your monitor like? It was this huge. And did you like it? You probably did. It was fine at that time. I hope you had a good monitor. Right? But over time, my monitor improved a lot. And my language improved a little. So I wouldn't call it 1995 design anymore, but it's probably 1998 design. And this is kind of a mismatch. You know, we have so much of improvement in the platform, in the hardware, in many other ways, but the programming language we're using is a little bit outdated ideologically. So this is why we're working on something new, because we think in very many contexts it will be really relevant. So now about this talk. So this is a talk about Kotlin's internals. How we craft the things under the hoods. So you're supposed to be interested in subtle details and stuff like that. How many of you knows much about Java bytecode? Okay, so it's more than 2.5 people in the room. That's great. Okay, so today I'll be showing a little bit of bytecode and mostly talking about the concepts, implying that you kind of realize how the bytecode works. Okay, so why should you care? If you know about bytecode, you probably know the answer already, but I'll still tell you about it. So any language is basically an abstraction. I hate the term syntactic sugar because it doesn't make sense. Any high-level programming language is syntactic sugar. And even the assembly language is syntactic sugar. So basically, whatever language you are working with, it has some means of implementation under the hood, and it's an abstraction. And any abstraction leaks at times. So you have this broad spectrum from your ideas about how the program should work, your programs being some reflections of those ideas, and that implementation under the hood that actually works there, and if something goes wrong, it may be very handy to like see through the matrix, right? And you know, Tetris is way too easy when played this way. So we'll be trying to peer through the matrix today a little bit. Since we are having this interesting improvement of the Java language, being the Java language staying as it was, and other languages kind of filling the gap between the state of the art and Java, it's a good question how each language does what it does. because there are very many interesting approaches to solving the same problems. And today I'm mostly talking about how Kotlin does that, but I'll give you some hints about other languages as well. Any questions at this point? Okay, by the way, okay.
How did you come up with the name Kotlin?
Okay, the question is, how did we come up with the name Kotlin? It's a good question. All right. It's actually a name of an island situated next to the city I'm living in. And all the Kotlin team is situated in. Any more questions? Okay, by the way, I would really like us to have fun together, so go ahead and ask questions as soon as you have them. So I don't like the situation when I'm a speaker and you are the audience, because in this situation I'm supposed to have all the fun, and this is not fair. Okay, so 2 words about me to put you in the context. So I'm currently leading the design and implementation of Kotlin. It's been over 2 years since I joined JetBrains to start the project. And I also serve on the expert group for Project Lambda in the JVM, in the JCP, sorry. So I'm kind of, serving the 2 different approaches to fixing the language situation of the JVM. Okay. So when you think about what you want to do to provide people with better experience programming, finally, our goal is to make a modern language for industry. And this modern is kind of a dream, a broad spectrum of things you can do, and industry is a constraint because you have to be reasonable. It's for hardworking people to use, not for dreamers to dream about. Right? So and this basically boils down to 2 most important things there. You want a smart compiler that figures out things people can figure out, and you want flexible abstractions that let you put interesting algorithms and interesting patterns of coding into the library, not to go over and over again doing the same code all the time. So Kotlin is statically typed. It's supposed to be readable more than writable. And of course it relies on lots of tool support, and we make huge emphasis on Java interoperability. And today I'll be referring to that all the time. Like, we didn't do that or this because we want to interoperate with Java and other JVM languages. All right, so let's start with some warm-up. I'll tell you about extensions. Who knows what extension methods are? 1 person, 2 people in the room. Good. So there is huge confusion about what extension methods are, in fact. So I'll give some introduction. So first of all, meet Kotlin. Are there any questions about this program? Since we're in this talk, there should be probably. Well, you're smart, of course, and you know how this should work. But anyway. So one thing you don't have in Java, and you straight away have in Kotlin, is a free function. So here I have my main function that does not sit in any class. How does this work? I have a package and a function right inside the package. What is it? How can this be? Java has all the methods in classes, right? So for a warm-up, you guess what we do there. Go ahead. Okay, so the answer is that we create a class per package, and our free functions are static methods there. So here is my bytecode view. We use it to debug our compiler. And really, there is a class called whatever extensions / namespace. And here is your familiar public static void main with the string array and everything. And you don't have to be fluent in the bytecode to realize what the signature is, right? Okay, now a slight extension to this. Currently I have only 1 file in this package, so you can put many Kotlin files scattered across the file system. But currently in this package, there's only one, and I add another one and say that I have another function there. What do you think? How many classes do I have now? One. And now still one. Okay, actually it's 3. And it doesn't matter how many functions I put here. It's 3 for 2 files and 4 for 3 files, so on and so forth. So you have one class for one file and then n plus 1 class for more than one file. And this is what it looks like. So here is a terrible name for this class. Guess what this number is? Oh no. No, timestamp would be very bad because the name would be changing all the time. So actually I don't like this implementation detail here, so we'll be changing it. But currently it's a hash code. Hash code is the string, the relative name to the file. This is stable but very ugly. I hate negative numbers there. So this is one class, and it holds this foo and the other function, also foo. And here's another class with a clean namespace, and a foo delegating to that other one. What do you think? Why would we put that there? Go ahead.
I would assume it's about visibility and interoperability. So you have this clean namespace in order to be able to call that from Java, and the other thing in order to fulfill visibility constraints? Or
yeah, so the conjecture here is that it's about visibility constraints. In fact, it's a little different. It's about debugging. The problem there is that you have those line numbers here all over the place. Are they in the bytecode view? I don't have any code, sorry. I'll put a piece of code here just to give you print one. Never mind the stack trace, it's okay. So I have these line numbers here. This is line number 4 in my file. And at the top, it tells me that it's whatever .class this line sits in, and this class file has only one source file associated with it. So when I step through my program, my debugger tells me, okay, you're at line 4, and if it's only one class for many files, I have no idea line 4 of which file I'm in. So I have to create many classes to work out the debugging. And by the way, it also helps figuring out initialization, because you may have a package level state. Like I can create a variable here. It's actually a final variable value. And the question is when this gets initialized. And the answer is, of course, when this class is loaded. And this class is only this file. So it's consistent inside the same file. So you have the logic of linear initialization. And if you have cross-references, it will be handled by the JVM. Any questions? All right. So now let's do something interesting. I'm removing the extra file to get rid of extra classes. Okay, so here's my printline function. It's a library function from Kotlin, as well as this main. It's a package level function. And of course I can define my other functions. Say I want a utility function last on a string. That will be last of string, and yeah, it will return a character. Give me a last character. Yes. Yeah. As of length -1. Okay, so here is basically the way you treat utility functions in Java. You create a static, so a class full of static methods called string util or whatever, and you put all your string utilities into this class. And it's terrible for two reasons. First of all, you have to say string util dot whatever function of that string, right? So it's extra string util there. And then if you want to do one operation and then on its result do another operation, you say it backwards. You say foo of bar of string, although it's first bar of string and then do foo, right? So this is why you would really prefer to put those custom utility methods on the right, like if they were members. And indeed, I think all new JVM languages let you do this. Java doesn't, and even Java 8 doesn't, but we do, and everybody does it in a different way. So I'll show you the syntax for how Kotlin does it, and then we'll discuss how it works. I can say that my last function is a function for string. So I have a string prefix for the function declaration. And inside this function, I have my normal this as if I were sitting in the string class. And this is how I refer to everything there. So here is my extension function. I added something to the string type so that you can call it with a dot and it shows up in the completion list. Here's the last and among other things. And there are many extensions in the library. So a big advantage from the usability standpoint is that you can learn your APIs just by hitting control space, like you do with class members, but that now includes all the utility functions. Now the question is, how does this work? What can it be? There are many possibilities. For example, Groovy would do this through expanded meta classes and scary stuff like that, so it will have some custom dispatching mechanism. Or you could imagine us digging into the string class at, say, class loading time and adding the method there, right? Is it possible? Almost not, because a string sits in the boot class path and it's protected. But yeah, you could even hack that into your custom version, so locally installed version of the virtual machine. Or we could do what Scala does and create an object that wraps the string and have this last a member of that object. But that would introduce another instance at runtime. Or we could do what we actually do. Here it is. We simply say, here is your normal static method that takes a string as an argument, calls it this, and does the work. So our approach to extensions is plain simple. You have your good old static utility functions in a nice syntax. If you call it syntax sugar, I don't like it. Okay, sure. Here is the bytecode for the method body, and here is the signature.
How do you access the array? Is it protected or
Array? No, there is no array access there, actually. It's another interesting part. So the question is, what are these square brackets for here? And your intuition is that it's the array that sits inside the string, but it actually isn't. It is simply a call to a get method, which is not in the bytecode either because it's optimized for strings, but never mind. So it's a convention in Kotlin. If you have a method called get, you can call it just by putting square brackets there because it's nice this way. Just no get. Okay, go ahead.
this get is an extension method that you put in?
This get is a trick method. So yeah, the question was, is this get for string an extension method? So under the hoods, we use the Java string. But we have our view class on the string because string is basically a built-in type. So it's not an extension method. It's in this fake class, which has no class file for it. And it's all translated down to whatever it is on a platform we compile for. We don't compile only for the JVM. We compile for JavaScript as well. And it gets compiled differently for different platforms. Go ahead.
Which namespace do you declare this method last? Will that be a
Okay, the question is, which namespace does this last sit in? So it sits in the package for this one, and to use it, you have to import either everything from the package or this method individually. So I can use it here because I'm just in the same scope, but if I want to use anything that is declared in the other package, I have to import explicitly. Go ahead. Yeah, great question. I was about to ask everybody, can you access anything private or protected on string inside this extension function? What do you think? No way. Exactly, because it's not in the string class. The security descriptor will just kill me if I do. It will be just a runtime exception. Yeah, so there is absolutely no magic. It is a normal static function that you can just call with a dot because it's more convenient this way. More questions? Okay. Go ahead.
Will there be an extra call overhead because you put inline it and then it simply returns?
Okay, the question is there actually a call to last? Currently, yes, we really call all the functions you declare, but we're going to implement something called inline functions, which are not actually called, but just inlined at the call side. In this particular case, it would make sense.
Does it really make sense? I think the JIT will optimize that anyways.
It's a good point. Yeah, for this particular case, it may not make sense. That's correct because because this is a very small method and it's very little overhead actually. But where it will make sense is when you want to allocate an object for a closure, you can get rid of all that altogether. Just no call, no closure, no megamorphism, no nothing. Okay, so I can demo it, so I won't talk too much about it. All right. So we're done with the extension example. And takeaways here are, first, our packages can handle free functions, but under the hoods they are classes with static methods. And extensions are static, statically dispatched. There's no runtime polymorphism. These are just nice form of calling your utility functions. Okay. Now let's talk about bridges. We're in San Francisco after all. Who knows what the bridge method is? Okay, 2 people in the room. That's great. So I'm sorry for explaining this, but everybody else needs that. So here is some class. It's a generic class, and I declare a function of t that returns the same t. You know that Java doesn't have runtime generics. So in the bytecode, there is the signature for this function, which is called generic signature, that is used only by the compiler. And for the runtime, the signature of this method is this. I abbreviate Java lang for GL. So I have an object parameter and the object return type. Now I want to extend this class. I make a subclass that says it's a child of base of int, right? So my t is no longer there. My t is now int, and I have int in and int out. The problem now is that I have changed the signature. And what does this arrow stand for? It's, yeah, something is not working, but what? Contravariance is not working, that's correct, but something more fundamental for Java is not working here. Yeah, so the problem there is that there is no override. There's just no override whatsoever because it's completely different signatures. And what JVM actually does at runtime, it matches the whole signature, including the return type. So you have 2 different methods. They don't override each other. That's a problem because what I meant was to override. And this is what happens not only in Kotlin. So it's not my stupid design that breaks everything. This is exactly what Java C does. And the problem is naturally solved by something called a bridge method, also in vanilla Java. So actually the compiler adds another method to the child class with a matching signature. So for Kotlin, this top type is any. So I have an any to any function with a matching signature that actually overrides, and it's a redirect. So it delegates to the custom version that the user wrote, casting the parameter to what it should be there. Okay. So, yeah, so why does this cast always succeed? And does it? So I have a cast there, so I have potential risk for a class cast exception. Yeah, so normally it will succeed because the compiler checks the types for you, and it wouldn't compile a program where this cast wouldn't succeed. But if you somehow get, well, yeah, of course, if you just have a raw type of base without t, without anything, and you call a foo, it now takes an object and passes a string into it, it will fail if you actually have a reference to child. In Kotlin, this is not possible. We don't support raw types. We fortunately can afford no backwards source compatibility with Java 1.4. We have binary compatibility. Okay, so this is what JavaC does, and Kotlin does, and everybody else does, actually. Now, there is one thing in this picture that is specific for Kotlin. It is this signature of the custom method, which is I to I. I in the bytecode stands for primitive int. What Java does here is Java-lang integer to Java-lang integer. And what we do is int to int. And it gives us some benefit. Because if you access the actual runtime type, so if you have a reference to child, you don't have any boxing. If you go through the base class, through T, you necessarily have boxing because you go through the object reference. But if you have just the precise static type, you have no boxing, no runtime penalty. Make sense? Okay, questions? Now, bridges are very widely used in many different tricks JVM languages play for in order to make things nicer. So the next example will be default arguments. Everybody hates overloading. I mean, no. Everybody on this side hates overloading because it complicates language design so much. We can't get rid of overloading because you have to be Java compatible, first of all. But we can simplify it so that you don't need it in very many cases. For example, Kotlin does not support overloaded constructors because with this feature, it's basically not needed. So what you see here is a function that takes two numbers and provides default values for those numbers. So you can say foo of no arguments and get two defaults and so on and so forth. The last option here is to specify the name of the argument you're passing so that you get the first thing by default and the second thing with a custom value. Any questions? Okay, so now there are a few ways of doing the implementation of this. And there may be different goals. For example, Scala generates lots of code for this method and like extra classes and extra virtual functions to make the default values overridable. Yeah, so if you want to override your default in your subclass, you want a virtual function there and so on and so forth. But so my intuition there is that you actually don't want to override anything because the contract at the top said it will be 0. If somebody else say, okay, I don't like zeros, it will be -1, something may break in the contract. So then there would be two strategies. You could, at every call site, emit the bytecode that creates those expressions, zeros in this case or something else if it's something else there, or you could do this inside the method. But to do it inside the methods, you actually need a bridge. And this is better because it's binary compatible. If you emit those zeros at every call site, You have to recompile everything if you change anything in the signature. And this is not very convenient. So to support defaults, we use bridge methods as well. For this declaration, we generate two things, two functions. One matches it exactly, so it has two parameters and the body inside this compute the sum and return it. And the other method, the bridge one, has an extra parameter which is a mask, a bit mask for which defaults were passed. And it says if the first bit is set, then take default for one, for the first parameter. If the second bit is set, take the default for the second parameter, and then call the other function. Any questions here? Go ahead.
Is it possible to use any operation on A to initialize B? For example, if you have a convenience, usually the strings you have something like offset and leg. So if you don't, if you give the offset but omit the leg, then the leg depends on the offset because it's
Okay. So the question is, can I, in the default value for one parameter, can I take into account the value of the other parameter? Yes, you can. So they are evaluated one by one. So if I want to say, if my offset is something, then the default is the other one. I can do it because if is an expression, you can put an arbitrary expression for the default value. It will be just evaluated there. More questions?
I just wonder about binary compatibility. If
Mm-hmm.
you have new methods, new parameters implemented there, cause the mass computed. Is this potentially an issue? I guess not.
Let me see. So if you add something that matches the signature of this mask in the same class, it just won't compile. It will tell you you have a clash of signatures. For one thing. For overriding, it won't interfere because it's a bridge method, basically. It won't hurt you in most situations. Yeah. More questions?
Yeah, this is a question about interoperability. How would I call the foo method from Java? Do I have to pass the mask explicitly?
So if you, by any chance, want to pretend you have default parameters in Java, you'd need to compute the mask. But otherwise, you just call the two-parameter function directly, because yeah. So basically, this mask thing is a bridge, and what you get is the foo one for Java, because Java on the client side doesn't provide you this capability of defaults. Okay. Now, oops. Yeah. Now another detail about this. Yeah, go ahead. Yeah, so let me check. So I don't remember what we do there. So let's see. I have this example here. And my base class has this foo method with one parameter. And, sorry, where's that? Oh, it's a child, sorry. So here's my foo. Okay, it's a different name. Yeah, this is what I suspected. Sorry. It will be just a different name here with the dollar that is not available in Kotlin. That's it. Yeah, so what I wanted to show you here is this. So I have a base class with some default value for this parameter. And here is my child class that is not allowed to provide anything here. It will be a compilation error because I can't override defaults. How many methods are defined in this child class? How many methods do I need there? It's actually one. Because this bridge method has only the single implementation. It computes the values from the mask and then calls the normal method. And all I need to override is the normal method. I don't need to override the mask method just because it's the same implementation for all classes. So here I'll have only one method in the subclass which saves you a little bytecode and makes things more straightforward for Java interpretability. So here is my subclass. Nothing special. Questions? Okay.
So I still didn't understand. Would you now have a derived class, a function which takes two its?
Yes, yes, you can. So let's just do it. So here is my fun foo of a int and b also int. It will have this exact signature here, and it won't override the mask one at the top because I had a mistake in my slide telling you that the name of the bridge method was the same as the original method. But actually the name of the bridge method is not foo, but foo $default. That's it. It's early in the morning. I forget my implementation details. Okay, more questions? All right. Now, go ahead.
You encode the fact that there are default values and annotations on the method arguments? Or?
Yes. For the compiler, you have to save the actual non-Java signatures somewhere in the bytecode. And the most convenient way is to put an annotation on the method. It's not only default, it's many other things. So we have this jet type info, jet method annotation, which carries flags and the returns and whatever, many other things.
But if the default, this bridge method has a suffix, this default suffix, how do you call it at the call side if you have a constructor? You always look if there's a default method first?
So what the compiler does when it resolves the call, it looks at the actually passed arguments. Then it looks if it can make these arguments fit into the signature, taking the defaults into account, and then it emits the according bytecode. So if any defaults were used, it will be the mask method. Otherwise, it will be the original method. Okay. Okay. So next thing is code and interfaces. And this is a contentious point because they will have it in Java 8. There is a question.
Yeah, sorry.
Yeah.
There's an extra overhead because you have to switch for the mask. You could have done it statically, but you haven't.
Yeah, for binary compatibility. Okay. Let me.
To make sure that if the default value changes,
Yes. Okay, so back to traits. People want code and interfaces for different reasons. First of all, multiple inheritance was taken away from us long ago. We want it back. We can't get all of it back, and different languages, again, do it differently. For example, Groovy gives you something like categories, dynamic mixins, and Scala gives you also traits that can even carry state. Kotlin doesn't give you state and traits. They are still like interfaces, but you can put code into it. And Java 8 gives you also some code and interfaces, but it behaves in a funny way so that it doesn't always work as you expect it to work. Because if you have a class method somewhere in the hierarchy, it always beats the interface method, even if the interface comes later in the hierarchy. So if somewhere you have your foo and your implementation comes from the interface, no way it will beat it. So we do just traits, so there is no this funny effect like Java 8. And the question is, how do you do it? So here's my trait. It's compiled down to an interface, obviously. And so far, you can't put any code into the interface, and until Java 8, it won't be allowed. So what do you do? How do you put any code in your interface? Any suggestions? You can copy the code. Yeah, you can say, okay, I have some kind of storage for my bytecode, and whenever I have a subclass, I just copy the implementation from the interface to the subclass. This is bad. Binary compatibility, bytecode size, everything. It's just very bad. You can do a little better. Not all much better, but a little better. So what you actually do, you put a static class next to your interface that carries all the code, and it's called whatever, trade $impl. With static functions, the signature here is wrong. I'm sorry, it's a typo on the slide. Actually, the foo takes an argument of type trait, of course, because it's needed this. And then, yeah, so here at the call side, I didn't make the mistake. And in the class that extends the trait, there is no explicit code that accesses anything, but we actually made a method that would call this static implementation. Any questions here? Okay, go ahead.
Do you allow inner classes and traits?
Inner classes and traits, yes, we do.
What if I call this inner class impl?
Okay, yeah, well, this impl is just a stub name. It will have some numbers there, and yeah. Yeah, but in general, you always can write some code where a compiler will complain that you have some name clashes. Even in Java, you can do that. All right. Yeah, so what I do here, I simply redirect to this static method. And then if somebody changes the interface in the library, I get the changes to me just because it's a method call, not just the bytecode injected there. Now, the interesting part comes when there are a few traits extending each other. The thing is that, okay, at the top, I had a method, then there was no overriding a trait, and then I extended a trait. So which one should I call? The one above me or the one at the top? What's the answer? Well, it's drawn there, but why do I actually go through another method call? Why don't I just call the top one directly? Yeah, it's the same answer, just binary compatibility. Because if somebody evolves the T2 trait and adds the method there, I have to be able to handle that change. I have to be able to call the actual overridden implementation. And I have no power at runtime. Java 8 will actually alter the resolution mechanism. Invoke virtual and invoke interface will work differently. But I can't do that. I don't have a virtual machine at my disposal. Yeah, so this is how it works. Questions? Okay, so it can't be all perfect. I mean, there always will be some binary compatible changes, of course, like in Java, like everywhere. But it's pretty good if you don't do too crazy things. Okay, so the summary for this part of the talk is that sometimes you just need another method. Go ahead.
Can you show the last slide?
Yeah, sure.
Does it mean that I always implement full in derived class or in derived trait?
Yes, when you extend a trait, you always have the implementation. It may, I mean, not in a class. In a trait, you always have a redirecting implementation. In a class, you have to implement it somehow because it's a concrete, if it's a concrete class. In an abstract class, you don't have to. Make sense?
Yes.
Okay.
That if I have 5 traits, dependent on each other?
You have a long chain. That's right. Yeah. Yeah, but this is a chain of trivial calls. It will be inlined. It's okay. All right. So next big thing is collections. Collections are actually as important as any language feature, although it's a library feature, but you use them so much that they basically shape the whole experience. Oh. So every new language basically comes up with its own collections. These are another way. And there has been a difficult story about this, because if you look at Java's collections, there are many problems. People don't like them this or that way. And so language designers tend to say, okay, those collections are just bad. Don't use them. Use our collections. They're better and incompatible. Which means that if I have my huge Java project, I have to convert all the data back and forth to interoperate with the existing code. And that's sad. But Java collections are really problematic. So what do you do? As usual, we can play some magic. And do something like this. So have a look. This is the Kotlin collections hierarchy. You have the green part. If you can see it, sorry about that. I'll just read it aloud. So the green part there on the left is iterable collection set list. All the familiar names. The change is they are immutable. Well, actually, they're read-only, not immutable. And they say out T there because T is contravariant. Kotlin has declaration side variance. You don't have to say question mark extends integer or question mark extends whatever on the call side. You can just say, okay, my class is always covariant in this parameter, and you're allowed to pass your, say, list of strings where a list of any is expected. So let's just show how it works. Sorry. Here is my collections example. All right, so here's my print. It takes a list of any and prints it out. And here is my list of integers. It's a value, its type is inferred, but it's inferred to be an array list of integers. And I can freely pass it here. It's okay. Because my list class is not the Java util list. It's Kotlin list, which extends the collection and has only the reading methods. It has no mutating methods. So it can be covariant and E. It's fine. Okay. Now the magic comes in. This is Java util array list. Okay, so that was a Kotlin class, and this is a Java class, and we didn't alter the JDK, but this Java class extends the Kotlin class. And again, you can't do any like runtime magic. You can't alter the classes at loading time. So back to this hierarchy. Of course, all those read-only classes are fake. There are no class files for them. It's just the type system fiction for the better experience. And you have mutable collections hierarchy, which basically replicates the Java collections that extend the corresponding classes from the Kotlin perspective. And your array list and hash set and everything extends the mutable ones. And of course, there are implementations for immutable ones as well. Not all of them already in the library, but that will be there. Now there should be a big question. What happens to the interop? The problem there would be, okay, so here is my custom implementation of the shortest class I could find, which is iterator. So it's the read-only iterator. Doesn't have the remove method, right? So to implement it, I just say has next is that, next is this, and here is my bytecode. Is there any bytecode? Yeah, here it is. It's has next and next. And at the top, it says that it implements Java util iterator. So there should be a question. Where is my remove? Like what happens if I pass this object to Java and Java calls remove? What do you think? One option would be not implemented exception. We actually throw another exception, but yeah, the point is that there is an implementation for the remove method, but what it says is create an unsupported exception, throw it. So if I just say, so I have this class here that takes an iterator, the Java class, takes an iterator and removes everything from it. And if I want to call this from Kotlin, collections test, it is collection test dot remove of my iterator, just create a new object. Here it will be an exception at runtime, of course. But this is basically what you're used to have in Java, because this is what happens when you say this unmodifiable collection and pass it to something else that would like to modify it. You'll get an exception. In Kotlin, you're just not able to call this. It won't work. Questions? So it's basically, it's again one more method, but this method is not for calling, but for just guarding for being called, against being called. No questions. Okay, so this is actually one of the features I'm really excited about because it makes the world so much nicer with so little effort. And you get the Java collection hierarchy fixed with absolutely nothing invested into the infrastructure. It's all the compiler magic. Go ahead.
How does that work with my Visual's custom collections and Java's collections and stuff?
Straightforwardly. So if you have a bunch of collection classes, they actually fall into this category there, where ArrayList and everybody else sits. So yeah, I'll show it in a second. All right. So this is the translation strategy. What I have here is my list trait just disappears. It's not in the bytecode. My mutable list corresponds to Java util list. And if I see that something in Java implements Java util list, I just say, okay, it's a mutable list. That's it. With Guava's immutable collections, we'll need to play a special trick for these particular classes somewhere in the configuration of the compiler to say that, okay, these are actually immutable. And if I have time, which is unlikely, I'll tell you about this mechanism. So now if you compile the Kotlin's code that uses lists, it will be always Java util list in the bytecode. And yeah, this is what I showed you about the fake methods there. And now the most interesting part, which is not fully implemented yet, is that for Java, these methods have write signatures as well. So if you have your covariant list there, it will just say $extends something. It will work even for Java. A little trick there is that when you're calling Java from Kotlin, Java only says list, doesn't tell you which list it is. So the default is to take the most permissive strategy. So if the method in Java takes a list, it will be a read-only list. You can put anything there. And if it returns a list, it will be mutable for you to be able to call anything there. So with this very little effort, we can make our collections better than Java's and still compatible. Questions? Okay. So the last part will be about nullable types. It's again the story of safety. Basically, the collection story is the story of safety. And here is a short introduction. Here's my piece of code about Java I/O file. So this is a standard Java I/O API. What's the risk here? If I call this size, the compiler complains. It's because this list files has a funny contract which gives you a null if the file does not exist or is not a directory. So Kotlin knows that this is nullable. If we look at the type, it will be an array of file with a question mark at the end, meaning it may hold a null. And these files now cannot be dereferenced right away. You have to guard before you do anything to it. So if I say if files is not null, I can now dereference, but without it I can't. So this is purely in the Kotlin's type system. It's not anything actually connected to the Java interop. But the question is, how do I know that this file, this method in the file API is nullable and say name, get name is not nullable? The answer is I basically don't. And the default is to treat everything as nullable if it's not primitive. Everything that comes from Java is nullable. But then I would end up with something terrible like this. Like an array of nullable files. Right? It's bad. It's very inconvenient. And we provide something called Kotlin signatures. Oh, my ID is terribly blinking for some reason. Sorry about that. So a Kotlin signature is, yeah, it even fits on the screen. It's something like this, where you say, okay, Kotlin should see this method like this, without the question mark at the array. And the compiler will just look at the signature and know what's nullable and what's not. The good part about it is that actually the bad part about it is that we started with annotating manually. Like you have a compilation error, you go to the JDK, you put an external annotation on a method, and you're fine with this method. But there are a dozen other methods that you didn't annotate, and every time you go there and annotate, it's not too bad, but it's pretty annoying. And last week we almost finished, and it will be out maybe in 2 weeks from now, a tool that actually figures that out for you. So it just does all the annotating automatically from the bytecode. Go ahead. I have very little time, but I'll try. So the thing is that you have the bytecode from your jar. And you can see if something definitely returns a non-nullable value. You can see if something accesses its arguments without checking for null. And these two things mean that you're either returning or taking a non-nullable value. You can also see if you modify a collection. So you can infer if the list is modifiable or not. You can see if you check something for null and throw an exception. It's again a non-nullable thing, so on and so forth. So there are a few heuristics that cover maybe 85% of the whole thing. And then the rest, very little, may be taken wrong, and you will just correct the annotations and send it to the central repo so that everybody gets the right annotation. And the good thing about it is that it's not only for Kotlin, it fixes things for Java as well, because the IDE knows the annotations and just does the analysis for you. Okay, so my time is up, and just welcome to the Kotlin world. I don't have any internet connection here, sorry about that. So you're welcome at all our resources to check things out, to contribute to the open source project, to ask me questions. Thank you very much for your attention.